Hello guys, welcome back to class. In this session, we'll see most important topic in the world of data science, data analysis is pandas. So this will study as various modules. In the first module, introduction module, we'll understand what is a pandas, why it is required, how to install and import, what are the pandas data structures supported and how to use them, and reading the files data. So mostly pandas is for data analysis, right? Where you will keep data definitely will be in a files, because it's not for a small data. You may have very large data sets, maybe data in Excel file, data in CSV. Most commonly used format is CSV file. Even if data can be in XML, data can be in JSON format, whatever. But generally, if you see data sets in the industry, the data sets are represented mostly with the CSV formats, comma separated values, because easy to read, parse for that reason. So if you have CSV file or even Excel file, how to read it, the basic things we'll understand in this. So Pandas stands for PANDA, is a panel data. Stands for panel data. They just combined as, it is a powerful library from Python. NumPy is what we have seen previously. That is one library from Python for numerical data storage, right? For data storage, array representations. And this is a library for data manipulation, data cleaning, and data analysis. These are all important sections in EDA, elaborative data analysis. We'll see this. This is a key in the data science area. If you are a data scientist, data analyst, the key job is this. So we will study this as a part of our course, because before you start your machine learning algorithms, before you write your machine learning models will work on the data. Machine learning models will work on data. Where you will get data? Data will be in data sets. When you have a data in data set, and if you want to run your machine learning models, before that you have to clean that. There are a lot of techniques to do that. That standard, industry standard is EDA. Elaborative, EDA stands for elaborative data analysis. Elaborative data analysis. That is a separate module for us. We'll study thoroughly later, but the EDA is fully depending on pandas only. And EDA has techniques, industry standard protocols to follow. We'll follow that. By using pandas library, we'll do that. Fine. It basically supports two data structures. One is the series, Pandas series, and Pandas DataFrame. Series is a 1D labeled array. It's a 1D array, but it is a labeled array. 1D array, labeled array. And DataFrame is a 2D array. You can call it as a 2D data structure or 2D array. You can consider a DataFrame as a kind of Excel sheet or SQL table is a table. So 2D array itself, a table, right? Which have a rows and columns. So your data frame is a 2D array like a table which contains rows and columns. Now series is a column. You can say data frame is, suppose data frame table is there. Suppose this is my simple table which has, I'm taking very simple SID, S name, SN, and email. So this is your data frame. This is your data frame. In this, how many columns we have? There are 3 columns. This particular column is a data frame series. This is a data frame series. Pen is not working. I am writing with the mouse. It is tough to write. This is one series. This is another column, series. This is another column, a series. So in SID column, what are there? All collection of twin IDs. That is a collection of elements, right? Collection of elements is a 1D array. Collection of elements, 1D array, and all of same type, right? And this 1D array is nothing but internally this is implemented as NumPy array only. Internally it is NumPy array only. Whatever operations you studied in the NumPy array, all operations we can use on the series, right? Internally they used it. Maybe in the pandas they have given other library. We can say that Panda is built on the top of NumPy arrays internally. And also it is integrated with other libraries like matplotlib, Seaborn, and scikit-learn. We'll use in the machine learning scikit-learn. Matplotlib, Seaborn are graphic libraries. You can do visualization of your data, right? So series and data frames. We generally won't use directly series because we will use a data frame. A table will create, means data frame will create. It internally contains the columns. Each column internally represents a series. Suppose if you want to work with names, if you take only name column, all the values, that will return as a series only, which is a NumPy 1D array. So whatever operations we know on the NumPy array, those all we can apply on the series. Fine, and we'll elaborate further. So it is mainly for data analysis, data cleaning process. Data cleaning has a lot of steps internally. As per EDA standard, we'll do that. Pandas is built on top of NumPy. Pandas is built on top of NumPy and also integrated with matplotlib. Means Pandas, if you have a data frame of Pandas, which has a table data is there. This data you want to represent in a visual format. So we can use a Seaborn or matplotlib. So they already integrated Pandas with matplotlib. So matplotlib can draw the diagrams like maybe a bar chart, histograms, float chart. These are all charts you can draw with the data available in the Pandas data frame. Okay, fine. And here I'm not exploring much about what is data manipulation, data cleaning, all that. We'll see on the way. And here is a term Purushottam is asking about what is the labeled data structure. What is the label, right? This point I'm not touching here. I'll explore it again. Okay, I'll explore it again. What is a label? We need to understand that. We'll understand it further. Okay. Next, what are the key benefits of Pandas? We have to go for Pandas. There are many advantages. Number one. So as I told you, Pandas supports 2 data structures, series and data frame. Can I say data frame is a collection of series? Because data frame is a table, collection of columns. Column is represented by a series. So data frame is collection of series. So we may not create directly series objects, but when you take one column, you may get a series, you may use operations on that. So we'll use mainly the data frame. We'll create data frame, we'll do various operations on the data frame. So the data frame is a tabular format, right? It is like a table. So the tabular data handling, there's the first advantage of Pandas is Pandas data frame is like a table. So it supports the tabular data for easy manipulation, number one. Number two, labeled data support. Number two is labeled data support. What is the labeled data support? For example, we have a table like this. I'm just taking two columns. This is the SID column. SID is the label, am I right? And I have S name. S name is a label, am I right? These are the labels. Generally, columns will have a labels always. Columns will have a labels. There's nothing new in this. This column label is SID, means the values you are accessing with the label. This column label is S name. You are accessing this column values using the S name label. Okay. And what about rows? Let's take, I have a student ID 1, name A. Student ID 2, name B. Student ID 3, name C. Now, as this is a 2D array, we have indexes for this. This index is 0, right? The first row index is 0. Second row index is 1. Third row index is 2. Like this, fourth row index is 3, like that. Indexing is there. Also, columns will have an indexes. Internally, it is a 2D array only. So this also you can access using index 0. Column, first column index is 0. Second column index is 1. So you have a rows having indexes, columns having indexes, but columns having labels. Rows also you can have a labels, guys. I can label it as S1. I can label it as S2. I can label it as S3. So if you want to access this particular row, first row, you can say index 0 I want. Or you can also access with the label called S1. Anyone. Or you want a row 1, R1, R2, R3. Your own labels, JLC 1, JLC 2, JLC 3. Any labels you can use. How columns your wish you are writing, right? Now I want to access 1, which is first row, first column. This column value I can access using label SID or the index 0. This particular C I want to access. I can access this with, I need, this is the third row, second column. Row can be accessed either with index 2 or the row label S3, or the column can be accessed here with the index 1 or the label as name. Labeling is clear. Rows and columns can have a meaningful labels for easier access and manipulation. Is it clear, Purushottam, now labeling? Generally, if you take a NumPy array you have only indexes, right? NumPy 2D array if you take, guys. 2D array means you have a rows and columns. 2D array is same as this only. You have a rows and columns, but rows and columns can be accessed only with indexes. Now we are using a Pandas DataFrame, which is kind of 2D array only, but which has a support for labeled columns and rows. Okay, next. It has a powerful data selection and filtering. This is a kind of table which may have so many columns at so many rows. Like you know, all of you know databases, SQL, you know, guys, a table is there. When a table is there, how you will get data from table? You write SQL queries. In SQL queries, how you will filter it, guys? You will filter writing the where condition, right? Simple where condition. But here, multiple ways. You can using the row column slicing, Boolean filtering, conditional operations you can use. Conditional operations mostly same as your SQL operations. And in SQL, how you write a group and aggregation, same. I want to fetch the data from this table, but we won't call here as a table. It is only data frame. Group aggregation support. We will write the code for that. No, you have a labeling for both the columns and rows also. That's what I shown. Rows also can be labeled. What is VM? VM means what name? Rows also can be labeled. Columns and rows both can be labeled. Next, importantly, missing handling data. Missing data handling. Built-in support for detecting, filling, or dropping missing values. Some values are missing in your data set. So what you will do? You may have a null values. So many null values are there for a particular column. What do you want to do with the null values? If nulls are there, you can't do analysis properly, right? So generally, if so many null values, you can drop the column. Suppose there are 10,000 customer data is there, guys. 10,000 customers data is there. Okay, means 10,000 rows are there. Okay, in this there is a city column. There is a column called city. In the city column, 9,000 customers, 9K customers did not provide a city value. You have only 1,000 values. You have only 1,000 values. 9,000 are the null values because not provided the data. Now, can you do any analysis on this city column? Can you figure out any insights based on this? Because most data is missing, right? Most data is missing. Do you want to do any analysis? Will you get any outcome? Okay, my customers mostly from this city. Can you decide that I want to find from where my customers are coming? Can you find any insights? Because data is not there. I don't want this. So I can drop this. First I'm identifying missing values. Okay, city column, most values are missing. What do you want to do? I want to drop this. You can drop it. This is how missing data handling missing value, missing data. Or sometimes, for example, I have another called age column. I'm just considering a strategy. Age column is there. In age column, for a 10,000 customers, 9,000 provided the age. 9,000 provided the age. Only 1,000 did not provide the age. Reverse I have taken. Means I have most of data. 90% of data having the values. 90% of values are there. Do you want to drop this column age? I don't drop this. So I want to do some insights on which age customers more coming. Younger age coming or middle age coming or old age people are more customers to me. So you have a 9,000. What do you want to do with the remaining 1,000 values? 1,000 values not there, right? So that you can fill with some strategy, filling the values. You can fill that with already null is there. This 1,000 already null is there. We can fill that with mean value or mode value or a median. These are three common strategies: mean, mode, and median. I think mean, mode, this statistical functions. If not, no worries. In EDA, we'll discuss about this. Yeah, in statistics, we have this mean, mode. So we can find a strategy. We will take the mean, not, yeah. We can fill those null values with either with mean value or a mode value or median value. That is so what do you want to do? How Pandas will help you guys? Pandas has powerful methods for detecting the missing values. And if you want to fill the missing values, yes, you can fill with the minimum required value. Or if you want to drop the missing value columns, yes, you can drop the other facility. This is a key section. Data handling we can do with this. Data cleaning and transformation. Another technique we use in EDA, and Pandas has good functionality for this. Data cleaning and transformation. Maybe tools for reshaping or merging you have multiple data sets, you want to merge it or joining, replacing, converting data from one format another format. For example, in my data set, there is a column called, say, for example, what do you say? Datum called gender. Gender, the value they were written as male or female. Okay. The value is there as either male or female. So later, whenever you write the queries, you have to compare always with a male or a female. So instead of this, I want to transform this to wherever male is there, I want to keep as 1. Wherever female is there, I want to keep as 0. I'm transforming my data into a different format. Okay? Or maybe you have a DOB. There is a DOB column, but I don't want DOB. I want years. So you can make a new column called years, age, otherwise age or years. And instead of DOB, or you calculate DOB and put the years value. Then you can, if you want, DOB I don't want, drop the DOB column. So something like that, you can do it, a transformation, converting data. Data cleaning and transformation, another good technique. And time series, this is also majorly for conversion. There are a lot of functionality. High performance, yes, this is built on top of NumPy. NumPy is super fast and more very good in performance because Pandas built on NumPy. It is very good in terms of speed and memory. Already we discussed why NumPy is super fast. Speed and memory also we understand, and interoperability because integrated well with NumPy, Matplotlib, Seaborn, scikit-learn. So we have various options and IO operations. Your data can be in any format, right? You may have your data in SCVS, CSV file, Excel or JSON, or you have data in SQL table is there. So you have a data in your table. So you want to read data from a table, create a Pandas DataFrame, then you can start analyzing, visualizing your data. The advantage, this is all what we learned step by step in this section. So installation is so simple. If it is not installed in your pip, install Pandas. If you are using Google Colab, mostly in Google Colab, it is already installed, readily available. But still, if you want, the only change you observe here, this you are using extra, remaining command is same. Suppose outside Google Colab, we can install like this, here extra command is this. Once installation is done, you can import Pandas as PD. PD is the most commonly used alias. Industry almost is habited to use PD, so we'll follow the convention as it is. Import Pandas as PD, so that we can call our libraries as PD or something like that, right? Check version. So import Pandas as PD, then PD dot underscore underscore version underscore underscore. So I didn't install now in this, might be it is already installed, right? In Google Colab we have. If you are working outside, you have to install it. I shown you previously how to install NumPy. Outside environment, yes, you install NumPy, same Pandas also you do that. So current version of Pandas I'm using here 2.2.2. So if you want, you can uninstall Pandas from Colab, Google Colab, you can uninstall it, current version. Still you can install higher version if you want. Okay? That simple for installation and importing. Next. So as we discussed, there are two data structures supported by Pandas, Pandas Series and Pandas DataFrames. Let's see how to create a series. Series is a one-dimensional labeled array. Series is a one-dimensional labeled array. You can think as a column in a Excel sheet or a single column in a table. Simple. And you can just create as there is a series class in the Pandas library. We can just directly use pd.series of pass the list of values. Pass the list of values. So series will be created. Suppose consider these are the marks of a student, guys. These are the marks of a student. Maybe all we are creating. These all will go in a single column, right? 10, 20, 30, 40 like that. Now, what are the indexes of this? I'll just make this as S1, series 1. Let's see the next and tell me what is the difference you're observing. Period at series of, my series data is this, and index is what it means, guys. Labeled data, yes, yes, yes. You can also write for clarity, not required, data equals to, this is data. This is data. Okay, and first series 1, when I create, I didn't use the indexes. So series 1, what index will come? Indexes will be 0, 1, 2, 3. And here I am giving index as ABC. Okay, access my series 1 data. Display this, you see how it works. If you want, just make 40 also. Make it as D also. See the output? I think you understand what is the labeling. You understand the labeling? Data you can take as normal as a list only. Data as a list here. Data is a list, simple list. So this is an index, similar to index only. See, you can say 0. We are normally 0, 1, 2, 3 calling as indexes, but you can say label 0 is a label. You can call like that. 0 is a label, 1 is a label, 2 is a label, 3 is a label. A is a label of the first element, B is a label of the second element, C is a label of third element, D is a label of fourth element. Can I do like this? We got 10, 20. You tell me how to get it from series 2, guys. You tell me the syntax to do from series 2. Print the values from series 2. My series of A or is this correct? Think and tell me. Single quote A or directly A? Single quote or double quote also fine, no problem. Because that can be represented either with single quote or double quote, no problem. We got the 10 and 20. Understand? Now one guy asked why this is row wise. No row wise. This is 1D array, right? 1D array they are displaying like this. But usually what we do, When we represent arrays, we have seen arrays like this only, right? Okay. Here is the 10. Here is the 20. Here is the 30. Now we see index is 0, index is 1, index is 2, label A, label B, label C. Got it? That is array only. Prasanna, that is array. This is a 1D array. Series is a 1D array only. Internally it is 1D array only. On the top you are seeing as a Pandas series object. But internally it is NumPy array only. Internally it is NumPy array only. So series is clear. And series has a lot of API, lot of methods. I'm not talking here unnecessarily because anyway when you start DataFrame, DataFrame we will use all. Okay, there's a here just a given how to create a series. Can I have a duplicate index names? What do your guess? Purushottam. Question from Purushottam is, can I have duplicate names? Yes. No, yes, yes. It is taken D 2 times. Let's print D now. You got both. You got another series. You got another series here. This is giving another series. This is giving a single element. This is giving a single element. My series 2 of B is giving a single element. Now it is not identifying uniquely, Santosh. It is bringing all elements of this. So I will do this in a my S, simply S1 I am taking. Okay, my S, simply. With that label, whatever there, it is bringing all of that type of X, type of my S. It is giving another series. These two, it is checking that any label D is there. Any label D is there, yes. With that, single element found or multiple elements found? Multiple elements found. Because multiple elements found, I'll just make you one more, guys. Make this as a Y, make this as a Y, make this as a Y. And here, come back here. This I'll make it as X equals to this. And print X and print X. So what do you understand now? Tell me. This is X. This is X data type. X data type is numpy dot int 64 integer, and this data type is series. Y data type is series. So what do you understand? There is the single element with the label B. There is single element with the label B. With the label B, single element only there. So the single element, it is returning as integer only. One integer, done. But with the D, there are multiple elements found. Those multiple elements, it is returning again, it is creating, taking the D label, 30 is there, 40 is there. So creating another series and giving you the series. Yes, it is a series. D30, D40 is series. Series start. Clear? Okay, done. Next about data frames. So data frame is a labeled two-dimensional data structure. It's a two-dimensional data structure, which is similar to Excel sheet or a table with the rows and columns. So can I say data frame equals to collection of series? Yes. Each column is represented as series. If I have a data frame with the 5 columns, there are 5 series you're going to create internally. It's a collection of series. Now how to create data frame? Simple way and most commonly used way is we create data frames from dictionary. Means when you do practice, actually when you do practice, when you have simple data, small data, then we do most commonly dictionary, and this is a column. Dictionary will has a key and values, right? Key and value. This key is considered as column label. So it's going to create a column with the name only. So one column as name. Second column is in how many you must take the 3. If 3 values are there, here also you have to take 3 values. So here I will take the first hello, SRI, VAS and 25, 30, 35. So we got a 3 rows into this, 2 columns. And once you define a data, some variable, I just taken the variable MS data, or for easiness, I'll just make it as my data. Okay, you pass my data variable here for data frame. PD dot D capital data frame, F capital PD dot data frame of my data. Now it creates a data frame object. It looks like a table only, internal representation is table only. Okay. I'm just printing my data frame. So we have a table ready. Do you have any columns here? Yes, 2 columns. Column labels are name is a column label and age is a column label. And row labels here, guys, 0 is a row label, 0 is a row index. You can say row label also you can say. 1 is the row index or a row label. 2 is a row index or a row label. Still, if you want, you can define the explicit labels also. For this first row, I want to say R1. Row R1 is a label I want to make. R2 as a label. If you want to make a labels, yes, possible. We have further in manipulation, we'll see those commands. Fine, guys, just here I'm just showing data frame. If you print a data frame, it looks like this using a print command. But for data frames is the most commonly used case, or I can say there is no alternative for pandas. In Python data science world, there is no alternative or a competitor for pandas. Pandas only will be used for data analysis, cleaning, manipulation, etc., etc. So many things, pandas only will be used. Okay. If you use a print command, it will show like this. You can also do like this, right? Can I directly write df here, guys? Can I directly print df? We've seen the variables previously also. When you do like this, it prints the values in a little bit highlight way. Here, see the look and feel difference of data frame. You'll see like this, neatly tabular format, something like this. Understand difference? You understand? Okay. Fine. There are 2 questions. Ankit question is, can we consider call as a key row or values? This is like your table only. Column name is name only I taken. One column name is the hello is a value. Sorry, this column values are this. These are the column values, right? This column has a 3 values. But a row, this is your first row. First row has a 2 values only. 2 values only. Okay. And Santosh question. Is this support other dimensions also? No, data frame is fixed. Data frame is a 2-dimensional labeled data structure. It's a 2-dimensional labeled data structure. Yes, Anik, you are right. Yes, you are right. Name is a 1 series, guys. Name is a 1 series, am I right? Name is a 1 series. Age is another series. Just there are internally it is creating a 2 series objects. Internally, it is creating two series objects and linking with the data frame. Series cannot have another series. Series cannot have, because this is single value, right? This is always a value. This is cell, right? Cell always will have a single value. Same as your table, guys. This is single value. This is single value. And mostly the value types, see, if you see, these are all a collection of values, right? Data types are uniform, similar types, same type. Series is a, so series is a collection of values of same type. Collection of values of same type. But see, practically, you can also store different types of values. This series can hold different types of values also. Means age, you can take integer here, you can take string here, you can take something else. That is possible because a series can have values of different types also. But in general, in practice, in our real world applications, we will use similar only. But practically, it is possible to have different values because a series is internally a numpy. Series is internally a numpy array. NumPy array, you remembered. Have you remembered? NumPy array can store elements of different types. Because of that, bottom is NumPy array, which allows you to store different types. Practically, you can store different types. But in a real world applications, we won't go for. Column is age of a customer. Age always will have similar values. We won't keep different. Name is always a string only. We won't change it. DOB always same only, like that. So how to create data frame? Just we are seeing only how to create data frame. Okay, done. Next is reading the values. So we may generally when we do practice, when we do practice and all, we'll create some data frame like this. We'll create dictionary like this. Okay, in this dictionary, based on dictionary, we'll create data frame and we'll work on this. But on the real world applications, when you work on a project, we won't create dictionary like this because you may work on you may have a millions of records, right? We can't hard code all that in a dictionary like this. Your data is there already, maybe in a CSV file, maybe an XML, XSL file, right? So how to read it? Yes, you can read very simply like this. So read CSV. CSV file name you specify. myjlc.csv. This is myjlc.csv. So myjlc.csv file should be in your location, guys. Make sure you have that here. So how to make this myjlc.csv file? Okay, we have to make that. Now we'll do it. If file is there, fine. Print I won't use. I'll use this. This comes neat look and feel. So you know your file structure here, right? From your file structure, I'll take your queries. Let me to complete this small section, then I'll take your queries, guys. Okay. We need to have a CSV file and one Excel file I'll take. Fine. So let me to prepare this. Give me 1 sec. One minute, guys. I'll just download some file and take it. You can easily create some CSV file or something. Or wait. I didn't find any files here. Just let me to create one quickly. This is my Google Drive. So here I'm creating Google Sheets. And Google Sheet I'm creating with the name called MyJLC. Oh, not here. Fine. Okay. In this, I'll just keep SID, S name, phone. There's 3 columns. 101. This file is somewhere is there, but missed. Here, there's 3 records, more than enough. Okay, so this file, this is an Excel file. Let me download this first. I changed the file name, but still not modified. Yeah. I think here only we have an option download as CSV. Directly we can do that. Download as CSV file is there. Same file will come as a or here only you can rename it. Whatever you want, you can do that. So now I think we have 2 files there. These 2 files you upload in your file section. Now come back to our collab. The files, this is the file section. I think you remember this, right? Previously we used it somewhere. You click on this. Fine. Click here, upload. Go to downloads folder. I have these 2 files. Open. Your data ready? Okay. Then let's go. So simple guys, you have a file and path, you take care about that. Then read underscore CSV, pd dot read underscore CSV of this file and just print it. That's it. You got the data. This is only the standard we use. You may have a large data set. We'll use the data sets, further examples from Kaggle, right? You know, I think Kaggle, Google's venture from data science. Kaggle is a data science machine learning company where you find many data sets. We'll download from that. You may have thousands of records. We'll just pass and show it to you like this. And second is the Excel, myjlc.xlx. We just import and do this. We are able to get this. Okay. In Colab, already the supporting libraries required for Excel parsing is already there, guys. That's what it is working directly. I added extra command for you in Colab or in outside environment. Suppose you're working directly installing on your machine and you're using some other PyCharm IDE directly, not in a Colab, then you may not find the supporting libraries for reading the Excel files. For that, you need to install Open PyExcel. Open PyExcel. This library has to be installed. Okay. Here it is not required in Colab, but this is required outside for you to read Excel files. You can run here, no problem. but it shows as anyway it is required. Already satisfied, requirement already, it has already packages. So no problem. Reading and displaying it. Is this clear, guys? Introduction part is clear. And now you ask, what we studied in this module 1 is just very important basics. We have done it. What is Pandas? We understand why so many features are, and 10 features are listed here. Installing and importing, we have seen. Creating series and working with the series. Creating Pandas DataFrame and how to just creating and reading from files also. CSV and XSV I showed. Yeah. Now you ask your questions. Then we'll go for next important section. So by default, first row of CSV considered as a label. Exactly, exactly. First row always the label. Yes, you are right. When you see reading, guys, SID, name, phone is the first row, right? That comes as a column, heading. Now you can ask a question, guys. What if that is not there? Let's try. Let's try this. I will make a copy of this. No copy on this. Okay, let's do like this. So what I'll do, CSV file. Yeah, JSON also you can read it. Just read JSON file method name. There is a method here. See, we have options, guys. Read underscore CSV, read underscore Excel, read underscore HTML also. Read underscore JSON we can use. Read JSON is there. Read JSON. SQL also there. Read underscore all functions. HTML also you can read HTML. Parquet files. Parquet you I think remembered. Maybe not remembered means I thought you were all older students like that I'm telling. Somewhere we discussed about this. Parquet format, kind of serialization format in our old courses, Java courses. SQL table also you can say SQL query. SQL table you give from this table it will get it. But most standard way is either CSV or Excel formats. HTML we may not do that. Okay. JSON, read underscore JSON is there. Open Excel, no import, alloc. Alloc question is it required import? Nothing required, no imports. Import not required for us. Internal library is enough. You install it enough. Install it enough. It will use read Excel file. Internally we'll use that and it will read from Excel file. Okay, let's do this. I'll show you one more point here. My JLC 1.csv file I'm creating is now. Okay. In this, the first row I am deleting, the label row I am deleting. Fine. Something happened for this. Okay, now we have a my JSC1.csv file is. I just dropped that. You can import, I just drag and drop that new file, I got it. And what's the new file importance you're seeing here is, and what do you understand from this? See, you run this, otherwise you'll understand that. What's the point you understand? First row always will go for label. 101 is the label now, guys. Column name is, first column name is 101. Second column name is A. Third column name is 111. That is the label, right? Yes. But we can also, we can skip this. We can say that read because I don't have a header. Yes, Anik, you are right. We can also say there's a default behavior, but we can say that no, not required to provide a mandatory. Generally, we provide the labels as the first. We can say that don't consider my first row as a header. In that case, it will do it. That experiments all will do it. It is just reading only. Fine. Okay, guys, that's about this basics. This is not a calculator. It's just kind of conversion. You can make this into interactive like this. See, automatically graphs coming. This all anyway we have to learn it later, not now. Okay. Even you can edit this. Now any questions up to this pending? Quickly ask, then we'll go for next topic. So can we avoid show indexing while printing? No, this is the default behavior. Default behavior, we can't avoid index printing here. Next question, Ram Seshia. Why we are sorting data into a list? We are storing data into list only. Is there any data type can we store? Where we are storing data in list? Which example you are telling? Is this? Yeah, this is a most common representation is the list we use. Most common style we use as a list. But still, yes, you can also go for a, later we have, I'll show you, not only list, you can also use a tuple. That's a commonly used is list, but doesn't make any difference. See, here I'm going to show you, the next session I'll show you, you can create from a list of list also, list of a tuple also, multiple ways, but there's a common style of representing, we use store always that one. Okay, so done. Next, Abhishek. In one of previous examples, we gave the same label to 2. Is created another series. Is the case series index? Yeah, that series again have an index similar to that. Yes, Abhishek. That series again will have, this is series, right? This series, now this series index is a D. The label is D. This series has a 2 elements. Series is a collection of elements, right? Series is a collection of elements. How this is represented? We are representing kind of array, right? This is an array only, right? Which has 2 elements, 30 and 40. And what is 30 index? D only. 40 index, D only. That's a label. 30 label is D, 40 label is D. Okay? Still, label related, still we can change the labels and all. We have further cases. I'll show you further. Okay, guys, any questions pending on the top? Please paste again. It has scrolled. Any questions pending? Anek, what is the Anek your question? Can we get only row label? Yeah, we can. This is the row label, Anek now. Now, this row label is 0. This row label is 1. This row label is 2. That is also an index. But still, can I make a row R1, R2, R3? Yes, but I'll show you that further. We have a this adding labels, column name if you want to change, dropping columns, dropping rows, updating the data frame. That we'll see in a next. Read JSON simple, Vishnu. I'll write here, you do the practice, okay? You take my JLC dot, so JSON file. So first you write one JSON file, basic some 2, 3 records, 5 records, whatever. Even if you download a JSON having 1,000 records, also no problem. Get some JSON and put that here, drag and drop into this file locations. And yes, just do this. Read JSON. Okay, that's it. If file is there, it works. File is there, it reads, and you'll see data frame simply like this. There's no difference. I don't have any JSON files as of now readily available with me, guys. Where can I find JSON file? In our old Java examples, anywhere JSON files we used. You try it, otherwise I'll show you the same file I'll bring it. Instead of me typing all the JSON here, let's do like this. Okay, fine, guys. So that's introduction part. Yeah, we can convert. Maybe in Google Drive facility is there. From this file, I don't have option here to write into JSON. Yeah, you can try it. You try this. Keep in a file. Somebody has Santosh. Keep in a file and upload here. I'll download instead of me copying, doing all that. You just save in a file and keep here. I'll show you that. You keep all that in a file. Save as my.js or something. Okay, otherwise I'll do it. Wait, I'm copying now. Wait, guys. This is all correct only, right? Means again syntax, all that errors. Ready? my.json. Maybe there are some parsing errors in this. Parsing errors are there. I'll show you this. I'll bring a small JSON and I'll show it to you. Okay. You try in your own. Otherwise, I'll show you this in the next session, guys. So the remaining module 2 will start in the next session. We have many other modules. Or I'll try to complete this data frame creation. And we'll do it in the next session only. Any questions you ask regarding this, we'll see remaining in the next session. We'll see that. We'll work on that. Currently, we're learning only reading data. That's it. Next, we have to see a lot of things. Okay. Any questions pending? All are down. All are clear. Abhishek, I think your question is answered. Rakesh answered. Ram Sishya answered. Anek, how to get only row label? That anyway, accessing we'll see further. Okay, guys, we'll see that. We'll see remaining in the next session. So we'll see that we have to complete this module 2. Basic creating data frames, attributes, descriptive methods, selecting rows, modifying, transforming, sorting, and resetting. Data selection and filtering. From this, we will go for a bigger data sets to write multiple queries. Okay, we'll see this in the next session, guys. That's about today's session. Remaining with the next session. Thank you. Have a nice day.